I'm very glad that we are with Professor Jane Fountain today, and then who is a keynote speaker for us for DGO 2020. And I tried to go over a very short, introduction of Jane, and it's not possible. So we are very honored, and Jane, as you know, is our distinguished professor of political science and public policy at the University of Massachusetts at Amherst. And she has founded and directs the National Center for Digital Government since 2002. And she was selected as the world's 100 most influential people in digital government and one of the 14 most influential academics in digital government in 2018 and 2019 by Political. And she's a fellow and secretary of the board of directors of National Academy of Public Administration. And she has been chair and vice chair of all this, member of the World Economic Forum Global Advisory Board. Okay, and she's a member of American Bar Association and appointed member of the Commonwealth of Massachusetts Governor's Council on Innovation. And she's been awarded a number of, distinguished, for the distinguished achievement. And Jane Fountain has delivered keynote addresses and invited lectures in 23 countries. So without further ado, we know that her research areas are very well known in the community. So I will not bore you with the details, but she is going to be talking about today's topic on the moon. Very interesting title, The Moon, the Ghetto, and Artificial Intelligence, Enacting Digital Government. Thank you for joining. And then please go ahead. Here's Jane Fountain.
Thank you very much, Suna and Louise. And I want to thank you for inviting me to give this keynote address. And I want to especially acknowledge you for organizing this conference during a very difficult time around the world and making it available. I also want to recognize two people that some Digital Government Society members may not even remember. Larry Brandt and Valerie Gregg, a long time ago, about 20 years ago, were program officers at the US National Science Foundation. They are both no longer with us, but as program officers, they recognized the need for a new field called digital government research that would bring together social scientists, policy scientists, information and computer scientists. And this conference and this society is one of the things, as well as my center and other centers, that grew out of their efforts. So I want to recognize them. And also I'm going to dedicate this talk to George Floyd and to Black Lives Matter. And that is really the topic of the talk. What you're going to see for the rest of the talk are slides, not me. So with that, I'm going to do a screen share and set this up in this new world of recording from home. So this talk is called The Moon, the Ghetto, and Artificial Intelligence, Enacting Digital Government. I'm going to go very quickly through a number of slides, but the first is to recognize the person who first came up with this term, the moon and the ghetto, and I'm going to use it metaphorically. Richard Nelson is a very famous economist who is still with us. And he is one of the fathers of evolutionary economics and also a key leader in studies of innovation. You may know his work, Nelson and his co-author Sidney Winter on national systems of innovation. He asked in this book, which came out of a series of lectures in 1977, a very long time ago, if we can end a man on the moon, why can't we solve the problems of the ghetto? Unfortunately, it's still a question that I think we should be asking today, and it has new urgency. A lot of my examples will be from the US, but I think you can easily make the translation to marginalized groups in other countries as well. We might ask, do we still have a problem with bias and social inequalities? Here's Tom Piketty's book, one of many. Social and economic inequalities have not only increased, but they have increased to such levels that they've produced political instability as well as human suffering. When I say social inequalities in this talk, I'm referring to social, economic, and political inequalities. And AI, unfortunately, although it has great potential, and I don't want that to be lost in this talk, which will be a critique, is likely to increase inequalities. Why do we have such inequalities around the world? Without spending much time on these slides, we can see that the share of income earned by the top 1% of populations in many countries has increased since 1975. So we have now almost a half a century of growing inequality. If we think about the future and AI, and this is, I'm using a report here based on a series of studies at the Brookings Metropolitan Policy Program, we see that AI is going to replace some jobs, maybe about a third of jobs. About a third of jobs will be assisted with AI and greater automation, and about a third will be in the middle. They've done something I think many other countries should and must do, which is break down, you see on this map, down to the county level with great precision studies of the industrial base of cities, race, ethnic, occupational categories. The table on the right are occupational categories by race and ethnicity. On the left, you see different industries and the extent to which they'll be affected. So it's a very fine-grained analysis. Anyway, the point of this is social inequalities are not going away. And unfortunately, they are likely over the next 50 years or so to become much greater. So for digital government researchers, this is what we are going to be faced with in the context and the environments in which we study. This talk is devoted to computational algorithms and systemic biases within them. And they are going to be playing out in the context of these economic changes. So many terms here: machine learning technologies, algorithms are within them and power them. People talk about algorithmic decision-making, about big data, predictive analytics. I'm going to use the term algorithms or computational algorithms. There are many positive uses. Here's a long quote. I'll read you just pieces of these from the fine overview by Helen Margits and Cosmina Dorobantu. We have reams of data about citizens, about governments that we could be using to improve education, to improve healthcare, to improve the lives of people, to prevent crime, to think about how to reduce costs, both in the environment and transportation and financial well-being. We could be supplying these services cheaper, more effectively, better, in a more targeted way. But we have a problem with algorithms and with predictive analytics, especially in social areas, social services, of which there are many that we study in digital government. So here's just the précis of a famous paper by John Kleinberg and his co-authors called Discrimination in the Age of Algorithms. In the United States, in most other democracies, civil rights mean that you cannot discriminate under the law in applying public services. The problem is that many of the algorithms that are being used in machine learning and in predictive analytics actually do discriminate. And it's very difficult to see the discrimination, especially because mathematically and epistemologically, you cannot go inside an algorithm that learns. So what do we do about this? Another study by Solon, Barakas, Andrew Salbst. Solon's at Cornell, Andrew's at University of Southern California. They write in the California Law Review a very detailed analysis of big data, going through piece by piece the ways in which, as we build machine learning models, we may be introducing bias or reinforcing bias. What's the point of this? If we want to study institutional discrimination or systemic racism or systemic discrimination, those are, what that means definitionally is that they are built into the rules that are used either by humans, by bureaucrats, by government officials, or in this case, by machines. So we don't want to automate the status quo if the status quo is biased. And so if we do not look inside these algorithms and inside the data, we can reinforce, in fact, we can exacerbate these widespread biases. And we find them, I'm sure, in every society. So they say the way that the target variable in data mining or predictive analytics is defined can lead to problems. The way that data, the training data, are labeled and collected can be biased, can be encoding past prejudice. The way that features are selected, because many variables are actually proxies for race, income, education, encounters with the prison system, other issues. We don't see much attention to multicollinearity in model specification, and yet it is there. And any of you who have studied regression should readily be able to make this transliteration, if you will. Title VII in the United States prohibits discrimination, but it's hard to find this discrimination in these algorithms. There are many such examples here. Here's one from the Tallinn Digital Summit in 2018, a European Commission summit. They say that we must make these algorithms open. We must make the training data sets open so that they can be scrutinized and they can be analyzed. I want to look at some illustrations or use cases in order to show the current state of the art, some of the problems that we face, and then talk about ways forward. So let's talk a bit about face recognition, then policing and criminal justice, and then screening decisions more generally. These come under the category of risk analysis, scoring of individuals for various things, and then using those to make predictions about how well someone might do in different policy areas. We'll look at the fragile families challenge and then discuss some ways forward. Face recognition. So here's Joy Bulamwini, a researcher at the MIT Media Lab, who sets off to study facial recognition. She finds when she goes into some of the most important packages from Amazon, from Microsoft, and other vendors, that they couldn't even recognize a Black face as a face. This was alarming. And so she builds a white mask that she was wearing at the outset of her research, and that's what you see in the picture. What does she find? In 2018, in the Amazon recognition system, which they, by the way, refused to have NIST, the National Institute for Standards and Technology, validate and certify, that it does a pretty good job, 100%, in recognizing lighter males. For darker males, the error rate is a little bit, but not bad, 98.7%. For females, it goes down to less than 93%. And then thinking about intersectionality, gender and race, for darker females, the success rate or the accuracy rate is only 68.6%. This is obviously a problem if you have a tool that you want to use on the broad population. The problem here is in the training data. It's not that facial recognition is not capable of discriminating across faces of any color. It's simply the way that it was built. So the problem is in the design, but these are widely used. Here's Microsoft, and we'll be talking more about some of the large IT firms. If you gave it a picture of the young Michelle Obama, It thought it was seeing a young man wearing a black shirt. It thought Michelle Obama's hair was a hairpiece. So very little predictive ability here. And the thought of using this in the city or public services is quite problematic. These led not just Joy's research, but other findings in these areas led in 2019 to a series of 3 congressional hearings that were quite important. I actually have my students listen to them. They're long, but they're quite revelatory. The first session was on the impact of facial recognition on civil rights. The second on how we would ensure transparency when the government uses these. We found in that session that the FBI, the Transportation Security Administration, a number of police departments around the country were not using these properly, were not validating them, were not using them in a reliable way. Deeply problematic, and regulation is slow to catch up in this area. And then the third session was in the commercial space, what should the government be doing in terms of regulation? This has led to considerable news. Here are just a few headlines. And in fact, government and industry groups were asking the federal government, please come up with oversight and regulation, because we are faced with local governments simply banning facial recognition. Facial recognition turns out to be something that people really get. They have a visceral reaction. And facial recognition uses machine learning, of course, in the matching of faces to databases, and then in making predictions about not only who these people are, but what categories they should fall in. So let's turn to policing criminal justice, an area in which there are crime risk scores for individuals, there are crime risks for locations, down to very precise locations within cities, pretrial detention decisions, and a range of decision making because of the volume of these cases that we hope to be able to automate. Here's a recent article from the MIT Technology Review, the headline of which is, of course, technology perpetuates racism, and this is MIT talking. It was designed that way. Here's Charlton McIlwain, who has written a wonderful book on the history of Black software. It's actually the history of Black software developers, Black computer scientists, and it is meant to complement and to flesh out this idea of just white men creating software. But he says that back in the 60s, during the Johnson administration, the last time there were demonstrations of the size we currently see, part of the response was to start building databases in the Black community, mostly to identify protest leaders and to be able to surveil them and control them. So this idea goes far, far back. So we see in databases, and now more recently in AI, machine learning, algorithms, over-policing for many years in some communities. What this means is that the databases longitudinally overrepresent certain classes of people, certain areas of crime. And so when you use them to try to make predictions, obviously you're going to come up with biases, and the algorithms might reinforce and exacerbate over-policing and problems. And then when they get the results that one might expect, those simply feed into these databases as well. Kathy O'Neill is a mathematician who worked on Wall Street in hedge fund analysis and then turned to social analysis of predictive analytics. She discusses the kinds of feedback loops that perpetuate injustice. Someone who receives a high risk score may become unemployed. They may come from a neighborhood where other people have high risk scores. This may end up, if they were arrested, in getting a longer sentence and being going to jail for longer, which may increase the risk of recidivism. They go back to their neighborhood because of these data. They may find it harder to find a job. And so we find in these related areas of public policy and digital government that similar types of data will simply replicate problems in modeling. These are called runaway feedback loops, and there is increasing attention to them, both in the databases as well as in the algorithms that are being built. It's a very important concern because of the amount of collinearity we see. Here's an activist, this is also from MIT Tech Review, who is working to dismantle these algorithms in Los Angeles. And recently, the Los Angeles Police Department, just in April of this year, before the current protests, by the way, decided that they would end their use of predictive policing using software that was a 2020 GovTech award winner, PredPol software. It's been used all over the country in police departments, developed by a professor in conjunction with the LAPD, made to give very precise, real-time predictions of where crime is likely to occur. The problem is that its use, its implementation, and many of the assumptions built into it have produced problematic policing. Moving on, let's say someone is arrested. The question then becomes, should this person be detained before their court case? This is pretrial detention. Judges make these decisions. They make the decisions based on whether the person is likely to be a flight risk. Will they show up to court if we don't jail them? And secondly, are they likely to commit crimes before they go to court? So those are the two things that are assessed. In a very famous paper by John Kleinberg and co-authors from 2017, they examined for New York City and then for a national database, many tens of thousands of pretrial decisions made by judges. What gets quoted most of the time or cited from this report is the last point here, that their model, their machine learning model, does better than judges, that they could reduce crime rates by 25%, holding release rates constant, or they could reduce pretrial jail rates by more than 40% with no increase in crime. Sounds pretty good. But they say that they really don't know if judges are using the criteria that are laid out by law. They really don't know if there are other criteria that they use in their decisions. All they were able to assess are the data that they were given. And ultimately, they don't recommend that one simply use their model, but they do recommend that their model could be a way to get insight into what judges do. So going back to their paper, the 2019 paper on discrimination, they call for policy changes that would require data sets to be vetted, to be available, to be analyzed, and to be validated, and for algorithms to be validated as well. That the Achilles heel, they say, of all algorithms are the humans who build them, the choices they make. And so they are highly critical of simply purchasing and using algorithmic programs willy-nilly. There is a very large network right now that is putting $48 million into reforming pretrial decision-making in the United States. It's a huge problem. 12 million people are admitted to jail in the US every year, the highest incarceration rate and numbers in the world. Nearly 500,000 people are held in jail before their trials, pretrial detention. It's enormously costly. It's enormously costly to the individuals who are held, who may not even be found guilty. It's enormously costly to the prison system and to society. $14 billion is spent every year to jail those who haven't even been convicted of any crime. And we could ask about the democratic questions as well. So if we could have algorithms that would be helpful, that would be quite important. But so far, we don't have them. Let's look at screening algorithms more generally. in a report published by the White House during the last presidential administration. This is sometimes known as the Podesta Report on Big Data. In thinking about challenges, they recognized that the rights, both the privacy rights, but the civil rights of people in housing, credit, employment, health, education, and market decisions was quite important that those were preserved as we start to use big data and analytics more and more. Going back to Cathy O'Neill, in her very fine book, which was written for a popular audience called Weapons of Math Destruction, she goes through predictive algorithms, and she says that they are most problematic when they are opaque. That means usually proprietary, so that one can't examine the rules or the assumptions built into the models, when they are unregulated and difficult to even contest, and when they are scalable, meaning that they will affect large populations of people. AI Now is a research institute at NYU. They have gone so far as to say that public agencies, especially those responsible for criminal justice, health, welfare, education, should not use black box algorithms if they have not been validated, if they have not been reviewed. They simply should not be used. AI systems licensed from third-party vendors and those created in-house that are not validated, because they raise such serious due process issues. Let's look for a minute at the Fragile Families Challenge. This is a case where a number of, in fact, more than 100 teams of data scientists were chosen as part of a challenge to apply machine learning, to apply algorithms, to come up with the best predictions possible for a set of outcomes for what are called fragile families. Fragile families is defined in this case as families where the parents of the children are not married. This is a 15-year longitudinal database, a very high value database. More than 750 academic publications have been published from it, but those were not in predictive analytics. Those were general social science, sociology, child studies, education, social services, in a number of areas. It's a very well-regarded database. This May, they finished the challenge. Matt Salganik, a professor at Princeton, tweeted, if hundreds of scientists created predictive algorithms with high quality data, how well would the best predict life outcomes? Not very well. Fragile Families Challenge. There are a number of papers that have been published. The Proceedings of the National Academy of Sciences publishes the overview paper, and here's Matt Salganik. What they find is that the predictive modelers, using the most advanced algorithms possible, did no better than someone using OLS regression, no better than someone using 5 or 6 independent variables than they had chosen, and in many cases, no better than simply guessing at these outcomes. What they conclude from this is that policymakers who are considering using predictive models in criminal justice, child protective services, should be concerned. And they also ask the related research question, what does this tell us, since social scientists feel that they have tremendous understanding based on this data set, that it's not very good at yielding predictive results. So there are many, many questions that come out of this. Here are some of the results. You see that if you were using an R-square, you would be at 0.2 or less. And I encourage you to go and read these papers and to read their results, because it's probably the largest study with 160 different teams chosen as part of a challenge of the best data scientists. And it shows us how far we have to go, put it that way. The papers are published in Socius, Sociological Research for a Dynamic World, and you can find them there. Let's move on. In terms of child welfare, the Salganic Challenge Group cite the work of Virginia Eubanks, who is a colleague I know of some of you at SUNY Albany, and in her book, Automating Inequality, she focuses specifically on welfare eligibility automation tools, on child neglect and abuse assessments. And she shows in this book, very troublingly, how many of these, in their use, in their implementation, have been made to punish the poor, to harass the poor through heavy-handed monitoring, increasing eligibility requirements, pushing people out of the system rather than getting them the assistance they need. So the use of these tools is as important as their accuracy and their validity. What do we say about smart cities? There won't be a complete analysis here. Let me just say, in terms of smart cities, these are places around the world that bring together rich, poor, people in the middle. They are a place where migrants, refugees, and others go to get a start, to get jobs, to continue their journey in life. They are places that are full of neighborhoods that are quite diverse in terms of wealth, ethnicity, and other categories. They are a living laboratory for social inequality, either its reproduction or reducing it. So what kinds of projects are we doing in the area of smart cities that will reduce social inequalities? Or are we just chasing the next shiny object? And what would be the incentives to include more projects that would be valid and reliable and useful in reducing these kinds of inequalities? And I flagged the area of gentrification in many cities as something that is particularly fraught, because on the one hand, it can lead to more economic well-being. On the other hand, it can also lead to pushing the poor out and reducing their status even more. So conclusions. Some of the ways forward. Facial recognition. My colleague Eric Learned Miller in computer science, Joy Buolamwini, and other co-authors have recently published a white paper in which they propose a new federal office. I've discussed this with them at length, borrowing from the US Food and Drug Administration and the processes it uses to validate, to test, and then to certify new medical devices. And they say we should take facial recognition systems, think about the particular use to which someone wants to put them, and then do the validation and certification studies. And they should be certified by the government. Let me say here, there are many important uses for facial recognition in human trafficking, in tracking down child pornography, in medical issues. Some diseases show themselves on the face, and facial recognition systems can find them. But we don't have basically any regulation in this space currently. IBM, you may have seen just this week, their CEO, Arvind Krishna, sent a letter to the US Congress saying IBM is not going to use facial recognition technologies, and we're not going to use facial recognition technologies from other vendors, and we oppose and we won't condone their use for mass surveillance, for racial profiling, for violating civil rights. In that letter, which I encourage you to read, they propose that they are happy to work with Congress and with other companies to come up with the kind of regulatory structure and oversight that we need in order to introduce these technologies in a coherent way into democratic societies. The Tallinn Digital Summit, an EU summit in 2018, called for policy changes. And almost all of them call for making the training data available, making the algorithms available, making them stored, and the need for them to be validated and certified. Some countries and governments are experimenting with what are called algorithmic impact assessments. Canada has one on GitHub that they have out for consultation. There are papers on algorithmic impact assessments under the GDPR, the EU legislation on privacy. New York City is studying them. That's a way forward as well. We might take the view that some of the principles of agile government can be helpful in ways forward in this space. First of all, we need clear missions. And the points here, I realize there are many of them on this slide. The ones marked in red are, I think, the most important. Iterative processes. Let me step back and say, most of you probably know, Agile is first developed in software development, and it's seen as a counter, as an improvement over waterfall projects, where one specifies requirements in advance, you go off and build whatever it is, then you find it doesn't work very well, then you hopefully go back to the contractor, very slow, very clumsy, very expensive processes. They say, no, you should be doing continuous iterations, rapid prototyping, getting information from your customers. In this case, these are multiple stakeholders across sectors, and they should be diverse, and building that in as one goes through a process of continuous experimentation and evaluation. And that diversity of thought is absolutely critical. In a recent paper, 2020, again, with John Kleinberg, Rediat Abebe, and other co-authors, they say that they question whether automated decision-making can ever, even if it is validated and improved, can ever address structural conditions that relegate certain social groups to the margins of society. And they recommend that we look at root causes, origins of problems, and not try optimizing mathematically around them, and that we shouldn't lose the root causes in our quest to develop algorithms of greater and greater complexity. Let me come back to Richard Nelson, The Moon and the Ghetto. When you get to the end of his book, he doesn't wrap things up in a neat package, but what he says is that many of the problems, policy problems, this is now circa 77, that were not getting solved, that were so frustrating, seem to be problems that required institutional change, institutional structure. The problem was not lack of rational decision-making or lack of complex analysis. The problem was that these were issues that required organizational change. In a paper in 2001, Paul DiMaggio and Esther Hagatai called on students of digital equality to study institutional issues and not just to get lost in the numbers, because that's where you will find the motor to sustain these digital inequalities. So in clothing, I'll say what I always say, which is technologies are enacted by human decision makers, and unless we specifically design them otherwise, they will reproduce existing social, political, and economic arrangements, good or bad. For digital government research as a field, I want to recommend that we specifically think about orienting part of the research portfolio proactively toward reducing inequalities and biases toward marginalized communities. So thank you very much for having me.
Well, thank you very much, Jane, for the wonderful talk on the inequalities in algorithmic, predictive algorithmics, and it was thought-provoking. So maybe with the attendees over here, if you have any questions, raise your hand, and then you can turn on your microphone. Okay, Sal?
Yep. So thank you, Jane, for this great presentation. It was very inspiring and very interesting. So thank you.
Thank you.
My question is, should government policymakers not decide on who will develop these algorithms, because policymakers come always with their ideology, with their ideas, and this may influence the teams that will build these algorithms so that they orient them to what they believe good for the society. So should we disconnect policymakers from these decisions on who will build these algorithms? Or should we find another way to prevent from these situations? Thank you.
This is a great question. And I think the part of the subtext of your question is to bring up that there is bias everywhere, every decision, every perception, every framing of a problem, who we decide should work on the problem, who should be on the research team, who are the policymakers and why are they there, who elected them, what is their program. It's intriguing that machine learning, that AI invites us to look more deeply at these underlying social issues. I think we should very much take into consideration what you are proposing, at least rhetorically, to think hard about who should be designing these systems. One of the reasons I very much like the Fragile Families Challenge is that because it's a case, and we have these in digital government, we say there's something we want to build. Maybe it's a predictive algorithm, maybe it's something else. Here's the problem area, here's the outcome we're looking for. Let's have a competition. Private sector, fine. Public sector, fine. Academic researcher, fine. Send us your proposal. And let's put together a review team that is intersectoral, that draws from many different voices, and then have many teams competing. That's expensive, it's time consuming, but I think certainly for some of these benchmark projects that will be replicated in part around the world in many countries, we need that level of rigor. So it's a great proposal.
Thank you. Anybody else? Okay, Luis.
So Jay, thank you also very much for your talk. So I want to hear your reactions about this idea that I read in another book called The Ethical Algorithm. This is a book by Michael Kearns and Aaron Roth, where they actually are inviting every developer to experiment with operational definitions of many of the things that are concerns for fairness. So they said we usually talk about fairness in ways that are difficult to implement in an algorithm. But if we start experimenting with mathematical definitions of parity and justice, and we try to incorporate them into the algorithms, we may get into something. So what do you think about this idea?
This too is a very interesting idea. And this area in computer science, in analytics, data science, with the unfortunate algorithm FAT, fairness, accountability, and transparency, has been reorienting many data scientists toward these issues, which is basically building normative values into computing, into algorithms, which is quite intriguing. So experimentally, academically, yes, absolutely. We should be doing this. We should be thinking about this. So let's think about what happens when an algorithm, when a database, when decision analytics are placed in an agency, in a program. We all know the policy stages. Now we are in the implementation space. And lots of things can go wrong or turn out in unexpected ways. So I think, again, prototypes, experiments, careful monitoring of what happens in the implementation space would be quite useful. And here, I think these ideas about Agile, to experiment a lot, but be clear that what we're doing is an experiment, that it's provisional, that if we fail, fine. If it blows up, fine. We're going to protect the space. We're not going to just roll something out in a city and then after a few years realize, oh, we really hurt a lot of people. What a shame. Now we need to change and recontract. And so we have a lot of opportunities. And the best data scientists writing in this area are saying, look, data sets may be biased for a number of historical reasons, but we have an opportunity here to understand more about bias and to understand perhaps how to correct it. But that's going to be a question of political will, of social will.
Okay, thank you very much. Okay, Lucas, go ahead.
Can you hear me? Yes. Thank you. Thank you, Jane, for a very interesting presentation. I would like to ask about something which is maybe a bit more of a European perspective, since I'm based in Ireland, and we've been dealing with GDPR and related regulations since a while. And there is a lot of voices in Europe saying that despite all these benefits that are brought by those laws, they also may hinder innovation. And it seems like Europe especially is falling behind United States and China and other players in the domain because of those regulations. On one hand, we are kind of leading the peloton with rights and making sure that everything is ethical and correct, while we really fall behind in terms of technology and the benefits that the technology brings. So that I think also in terms of the dilemma you mentioned, like facial recognition, on one hand, it can abuse privacy. On one hand, it can help, like we see the controversial technology used in China, where it actually helped to contain the virus because of the very advanced tracking systems. And there is also a lot of other applications for facial recognition for health and safety. So that, what is your opinion on that? Thank you.
Yeah, so two things in the macro context. Number one, the virus, obviously. And look, there is an argument. If we had perfect transparency, if we all know where everyone is all the time and we could track them, there are some things we could prevent, crimes we could prevent, disease transmission that we could prevent. We have to balance these things with democracy, privacy, surveillance. There's no doubt in my mind that not simply predictive analytics, but the whole range of changes in information and computing are changing the way that many people think about privacy. Different democracies, if we were to take Europe, US, Japan, South Korea, have different laws on the books. They have different implementations, and you would see different uses of technology in terms of understandings of privacy and surveillance. They're quite big questions. Turning to this situation of innovation, I can tell you that in the past 30, 35 years of going to Europe, there's always, on the one hand, pride in a much more thoughtful approach to rolling out innovations that is in contrast to the US kind of Wild West approach. It is built into our national technology and innovation strategy to innovate first, identify the risks later, and deal with them after the fact. We now have a situation where the US as well is chasing China, to some extent India, to try to stay ahead in innovation. So the economics, you're absolutely right, are something that must be considered. The extent to which they can be allowed to predominate. I mean, these are really existential questions. Researchers thinking about fully automated factories, fully automated labor forces, and saying there's no way that a labor force, I'm getting far afield, or maybe just digital government, but these are important. There's no way that those industries would be able to compete unless they use these new strategies, which trample over privacy and are full of surveillance, as well as other things. They really raise the stakes for what some people might say this luxury of democratic ideas around the rights of the individual.
Right.
I don't have answers, but I do certainly think having debates and having these discussions and making more and more people aware is critically important. I know for my graduate students who are going to be government officials, who are going to work in nonprofits, etc., it's critical for them to understand these debates.
Thank you. Thank you, everybody. I think I have tons of questions, and then thought-provoking, talks always exciting because it gives me a lot to think, and then I'm sure it's been like that to you too. So thank you one more time to Professor Jane Fountain for joining us and then giving wonderful, insights, as well as a lot of interesting cases that we have to really consider in our technology-driven or machine intelligence-driven society. So with that, I think time is up, unfortunately, and then we would like to invite you some other time to the some other digital conference, digital government conference, which will occur in Korea once again in the near future. So we will reach out to you again. Thank you very much, and thank you everybody for joining. Thank you.
Yeah.
Thank you very much.
Bye bye. Yeah.
Bye.
Okay.